Hello students, today, we will study how physical quantities are expressed. Physical quantities are divided into two types, on the basis of their description. One type of quantities is scalar, which requires only a magnitude to give full information about them, like mass, temperature, and length. Whereas vectors are those quantities that require magnitude and direction for their complete description. For example, force and displacement both require magnitude and direction to understand their full meanings. But why do we need vectors? Let's understand with an example, where a person is asking the other one to displace a box, but the other person is confused because the box can be displaced anywhere due to its multiple directions. So he requires magnitude and direction to understand where to and how much to displace the box. To avoid such confusion, the concept of vectors is used, which fully expresses those quantities that require magnitude and direction. So in short, vectors are necessary to describe the meaning of physical quantities to avoid any confusion. In physics, vectors help us to identify direction of force, acceleration, and velocity. Symbolically, vectors are represented by bold letters notation or with an arrow. Arrows are used as they can be broken into length of arrow as magnitude of quantity and arrow head towards the direction of vector quantity, so an arrow can completely fulfill definition of what vector is. Without any complications, a single arrow can explain everything. Vectors have different types. First of them is unit vector. Unit vector is that vector whose magnitude is 1, and it is used to describe the direction of a vector. Mathematically, a vector is equal to its magnitude into unit vector. A hat sign is placed on a vector, which symbolizes a unit vector. Every vector has its unit vector. But what happens if two vectors of the same magnitude but opposite directions are added? Their magnitudes cancel out to give 0, but still, they have arbitrary direction, because the addition of vectors is not like simple numbers. To express those vectors, we use the concept of zero vector. For example, the magnitude of displacement in a complete circular rotation is 0, but the direction of displacement is not 0. So zero vector is required here to explain displacement in a closed loop or anywhere magnitude of vectors is 0. Two vectors of the same magnitude and the same direction are called equal vectors. For example, vectors A and B, whose magnitude are same and both vectors are pointing in same direction. So they are equals in both their magnitudes and directions. So they can be added like simple numbers, which increases their magnitudes and direction remains the same. If two vectors are in the same direction and on the same line, then they called like or parallel vectors. Why they are parallel? The answer is that the angle between them is 0. The meaning of the same line is that they lie on the same axis regardless of their magnitudes. Whereas those vectors which are on the same line but in different directions are called unlike or antiparallel vectors, because their initial points join together to form a straight line whose angle is equal to 180. As in figure, vector A and B are given with arrows pointing in opposite direction. A vector that is equal in magnitude but opposite the other vector is called a negative vector. For example, a vector A has its negative vector, which is equals in magnitude and opposite in direction. The difference between two vectors is shown by arrows, which are pointing in the opposite direction. A vector can be multiplied by a scalar, which are mathematical numbers. A positive number, for example 2, is when multiplied with vector A it changes its magnitude. Whereas when a negative number, for example -2 is multiplied by vector A, it changes its magnitude as well as its direction. So multiplication of scalar with vectors is categorized in two ways: change in magnitude only and change in both magnitude and direction, which depends upon what type of scalar number we used, positive or negative. To locate the position of a point in a plane or space, we use Cartesian coordinates. These are mutually perpendicular lines who are named in three dimensions as x, y, and z axis. A point is somewhere in a plane, then the vector from origin to that point is called position vectors, which is given by r. The coordinates of position vectors are x, y, and z depending upon whether it is in 2 dimensions or in 3 dimensions. For 2 dimensions in xy plane, a position vector can be written as ratio equals to xi unit vector plus yj unit vector. 2 coordinates are used because point is not any specified coordinate. I, j and k are 3 unit vectors of x, y, and z axis, respectively. Vectors addition is not simple as addition of scalars which are added like numbers. To add 2 or more vectors, we use head-to-tail rule. In this rule, the head of one vector is joined with the tail of the second vector, and the resultant vector will be joined with the tail of the first and head of the second vector. This is shown in figure. The resultant vector will have whole information of 2 vectors, which are added, and it alone expresses the whole information of magnitude and direction of both vectors. Vectors can be added analytically, where 2 components of one vector added algebraically with the other vector's component, but only those components are added with each other whose unit vectors are the same. Like a unit vector will be added with a unit vector. What happens if a vector is at some angle with a horizontal axis? The answer is given by resolution of vectors. Resolution of vectors is splitting of a vector into its components. For example, vector A, which is in the xy plane, has direction in both x and y axis direction. To solve this vector, we break it into its components. The horizontal component along the xy axis will be written as x equals magnitude of a into cos of theta. Whereas vertical component along y-axis is written as I equals magnitude of a into sin of theta. The resultant vector r, which is equal to a, can be found by Pythagoras theorem, which gives magnitude of a equals to square of its x component plus square of its y component under the root. Taking magnitude a squared as common, as we are left with cos squared of theta plus sin squared of theta, which equals 1, then magnitude is only a. This is the relation for a single vector to find magnitude. The direction of the vector is defined by the angle between the horizontal axis and vector A, which is given as angle equals to tan inverse of theta into y component divided by x component of a vector. Let find magnitude and direction of a force vector, which is given as force equals to 3i unit vector plus 4j unit vector. Magnitude of force is given by square if its x component plus square of its y component under the root. Here x component is 4, and y component is 3. By putting in formulae and simplifying, we get magnitude of force equals to 5. Angle can be found by putting y and x components in formula, and we get 36.87. For more than one vector at an angle with horizontal or splitted individually into their components, after that resultant of components is found by head-to-tail rule, and resultant vector is written as the sum of resultant components of two or more vectors. Vectors are multiplied in two ways. One is when two vectors' product is scalar quantity. This is called scalar or dot product. For example, AB equals AB cos of theta. Here AB is the product of magnitudes, and theta is the angle between two vectors. Dot product magnitude depends upon this angle. If two vectors are parallel, then the angle between them is 0, so the dot product will be maximum because cos 0 is equal to 1. Here, A and B two vectors are given who are parallel to each other, so putting in formula, we get only AB magnitude of two vectors. But if two vectors are perpendicular to each other, then the angle between them is 90. When we put this angle in dot product formula, we get cos 90 which equals 0, so the whole product becomes 0. This is shown by two vectors A and B which are perpendicular to each other. There is a third condition when the dot product is negative. This happens when two vectors are antiparallel, the angle becomes 180 and the value of cos 180 is -1. This value is putting into dot product formula gives -AB, which means dot product becomes negative. Dot product is used when we have to find work which is equal to force dot displacement. Here two vectors product is work which is a scalar quantity. We don't need direction to express work. It is also used to find magnetic flux, which is also equal to the dot product of magnetic field B and area A. The dot product of unit vectors is 1. For example, I unit vector only gives value when we take its dot product with itself. I mean, I unit vector. Because the angle between both vectors will be 0, the dot product between I unit vector and j or k unit vector will be 0 because they are perpendicular to each other and angle between them is 90. But if two vector products result in a vector quantity or a vector, then we call this vector product. Vector product of two vectors A and B can be written as A cross B equals to product of AB into sin of theta with n unit vector. Here AB is the magnitude of two vectors, theta is an angle between two vectors, and n is a unit vector, which is normal to both A and B. It describes the direction of cross product. To find direction of normal vector n we use right-hand rule. Point right hand in direction of vector A and curl fingers toward vector B, then erected thumb will give direction of n unit vector. Similarly, cross product of unit vectors I and j will gives k unit vector. Cross product will be maximum when two vectors are perpendicular because the angle between them will be 90 and sin 90 is equal to 1, so magnitude will be maximum. Here, two vectors A and B are given and arrows showing they are perpendicular to each other, so cross product in this case will be maximum. But if two vectors are parallel, then their cross product will be 0 because the angle between two vectors will be 0 and sin 0 is equal to 0. It is also true for antiparallel vectors, whose angle is 180 and sin also 0 at this angle. This is shown by two vectors A and B by arrows. Cross product of unit vectors maximum if product is between mutually perpendicular vectors. Like I unit vector cross J unit vector will equals to K unit vector. Similarly, K cross I unit vector is equal to J unit vector and J cross K unit vector equals to I unit vector. This happens by right-hand rule when we take cross product. For example, between I and J, then thumb will point in K direction or 0 axis. Whereas self-products of unit vectors will be 0 due to 0-degree angle between them. Cross product of two or three vectors can be found by the determinant of two vectors. Here I, J and K unit vectors are written in first row and components of vectors x, y and z below them, which on cross multiplication gi especially desired cross product. Torque is an example of two vectors, where moment arm cross force gives torque. This is visualized in daily life when we open or close nut bolts where R and F are perpendicular and the movement of nuts gives n unit vectors. Thanks for watching. Bye till next video.